Hi everyone. Today we're going to be working on solving inequalities that will have real or imaginary solutions. This should look pretty familiar, so let's just jump right into it. Solving an inequality like number 1 is just like solving an equation. We will simply subtract the 5 from each side and then divide by 2. We get a solution of x is all numbers less than 4. So this is what we call set builder notation, but in interval notation, we would say that it's a set of all numbers from negative infinity to 4. And seeing that it just says less than 4, we put a parenthesis around the 4. Okay. Number 2 is a compound inequality. So we're going to have a number that's going to fall, or a range of numbers that fall between two numbers that would be our solution. So we just have to balance all three parts of this. So we will subtract 1 from the left, which gives us 5, the middle, which leaves us with negative 3x, and the right side, which leaves us with 9. So that kind of gets rid of that. And now we will divide all three sections by negative 3. So remember, when you divide by negative, you have to reverse the inequality symbols. So what we have here is a solution that falls between negative 3 and negative 5/3. Okay, and so if we were to write that as interval notation, we would have a bracket on the negative 3, being the smaller number, by the way, okay, because it says less than or equal to, and the solution goes from negative 3 up until negative 5/3. And of course, if you wanted to write that as negative 1 and 2/3, that would work just fine. Okay, moving right along, number 3. Number 3, we're going to factor. So when we factor this, it's pretty simple math. We have x plus 1 times x plus 3 is less than 0. And when we solve that, we get negative 1 and negative 3. Seeing that we're dealing with an inequality, what we have to do is we have to kind of look at a number line, put these numbers on the number line, and figure out which region or regions will give us a true statement. So one thing that I would have you notice is that the symbol here is less than, which means the x can't actually be equal to negative 1 or negative 3. So we will have an open circle on negative 1 and negative 3. Now, when we have something like this, it's pretty easy to just pick a number to the left of negative 3, okay, between negative 3 and negative 1, and then a number that is greater than negative 1, and see which ones give us a true statement that all of that would equal something less than 0. In other words, we're looking for a negative number. So if we put negative 4 here, I think the easiest way to do this is to simply drop negative 4 in here. We would have a negative 4 plus 1, which gives us a negative, negative 4 plus 3, which gives us a negative, and we would have a negative times a negative, which equals a positive. If we choose a number between negative 3 and negative 1, I would take negative 2. Negative 2 minus 1 is a negative. Negative 2 plus 3 is a positive. A negative times a positive is a negative. And then, of course, if we choose a number over here to the right, I'm going to choose 0. 0 plus 1 is a positive. 0 plus 3 is a positive. A positive times a positive is a positive. Now let's remember, we were looking for where this was less than 0. So this is the solution right here. We're looking for that negative number. So in set builder notation, we would say the solution is from negative 3 until negative 1, not including either of those solutions. In interval notation, we're going to say that it falls between but does not include negative 1 and negative 3. Okay, so I'm going to have you pause this video and go ahead and do number 4. It is very much the same problem with just a slightly more complicated factoring. Okay, you're going to use ratio method. Pause the video, do the problem, and then start it up again. Okay, let's take a look at this. Hopefully you got the same solution. So the factoring, hopefully you remember to reduce with that lead coefficient. And because it says greater than or equal to, we're going to include these two solutions that we got when we solved the problem as an equation, okay? So that's why we have closed circles here. We test our regions and we're looking for positive numbers, right? Numbers that are bigger than or equal to 0. So when we drop some numbers in here, we got a negative times a negative. That's a positive. In between these two solutions, we got a negative number. And to the right, we also got a positive. So this is how we would write this. This is set builder notation. Of course, down here is interval notation. Notice the parentheses at the negative infinity and positive infinity, but of course the brackets on these 2 points right here because we are including those values in our solution. Okay, next one. We're going to solve this. We can't factor. It's not the difference of squares. It's the sum. So we will move that 1 over. We'll have x squared equals negative 1. And of course, when we take the square root of a negative, we get positive or negative 1i. Okay. And seeing that it's an inequality, we're just, oops, I forgot. I changed my sign by accident. Sorry. X is greater than or equal to positive and negative I. Sorry about that little mistake. And that's it. We're not going to graph that. Okay, the next one. Okay, hopefully you can see that we can take out a GCF. So we're going to factor out our X. We'll be left with X minus 5. Okay, and this is very similar to the previous ones. We solve each part using zero product property and we get 0 and 5. And of course, we will check this on our number line. 0's right here, 5's right here. Hopefully looking at this, you knew right away because it doesn't say equal to, we're going to have open circles on 0 and 5. We're going to drop some numbers in. I'll take negative 1 from over here. A negative times a negative gives us a positive. A number between 0 and 5, I'll just take 2. We'll have a positive times a negative, which gives us a negative. And over here, we'll take 6, 7, 8, whatever you want. It'll be a positive times a positive, which is a positive. And of course, we were looking for negative numbers. So the solution falls between, but does not include 0 and 5, which will look like that in set builder notation, which our book loves to use. And in interval notation, it looks like this. Hopefully this is all review and you're remembering this. Go ahead and do 7 and 8 on your own. Pause this video and then start it up again and see if you get the same solution as me. One thing I would suggest on number 7 for you to do is to divide everything by negative 1. What that does for you is when you're factoring, oops, don't like that. When you're factoring, if we divide by negative 1, it'll give us a lead coefficient that's positive. But you also have to remember that you have to reverse that inequality symbol. And certainly much easier to solve when our lead coefficient is positive. So go ahead and do that. Okay, pause the video, do that, and then start the video up and see if we get the same answers. Okay, so take a look at the solutions. A couple things to notice. We solved, I didn't write how I factored, but I used ratio method. And we got the region to the left of negative 3/4 and to the right of 6 as our solutions. So again, set builder notation looks like this. Interval notation looks like this. We have the parentheses, whoops, here and here. Okay, because we are not including these values. Okay, and of course this is a symbol union, meaning both solutions. The next one, we factored the difference of squares, got 3 and negative 3, and then tested our values and found out it was the region between 3 and negative 3, including 3 and negative 3, which is why we have these brackets here. Okay,